It's a little bit early, but I went ahead and started the recording again. Let's see. Oh, here's our system.
You cut in and out, but now you sound like you're in a tunnel. So it might just be our Wi-Fi over here.
Let me see what I can do about it. Is that any better? Is the audio any better?
Sounds
or
good.
can... Oh, so am I still sounding like a tunnel?
Yeah, no, it's still like cutting out, but like I said, it might just be me.
Yeah, maybe it's just the weather. It cuts in and out, and you could.
Well, I'll try to speak more slowly. All right, so it took my share away. That's weird. Let's go back to the overhead. So we're going to walk through the solution to this system. We've got our initial matrix, and we're happy because we have what? Why are we happy?
We have a couple of ones and zeros where they're supposed to be.
Yes, absolutely. So one thing that we could do, we've already got a 1 in D11, and there's another 1 in row 2, pardon me, in column 2. If I switch these last 2 rows, then I'll have a 0 where I want it and a 1 where I want it. And that'll give us 1, -1, 0, -4, 0, 1, -3, -7, and 2, 0, 1, 6. So what do we need to do now?
So what would that be? The command is switching them, but for what step would the command be?
So the step would come in the second part of column 1. So column 1, we did the 1 already, and then part of the zeroing out would be the switching.
Okay.
And we just have one little thing left for the first step, and what would that be?
The 2 has to be a 0.
Good. And what are we going to multiply? Which row are we going to use, and what are we going to multiply that row by?
Row 1 and a -2.
Good. And let's work that out. So we've got row 1, -2 times row 1, row 3, and then -3. -1, -1, 0, -4, So what is -2 times row 1?
I'm not ignoring you. I just wanted somebody else to participate too.
Yeah, I know Tyler, Celeste, Maya, Tanya, Victoria, Amber, Jay,
I'm
Kim.
sorry, my space. I don't know why it's not like working when I press space. So like it's hard for me to like write the notes and like move my mouse to unmute at the same
I
time.
understand.
Like, yeah, I'm sorry.
No, that's okay. Just tell me what our new row 1 is.
Okay, it's gonna
Hi,
be
Vic.
-2 0. I mean -2 2 0 8.
Excellent. And our current row 3 is 2, 0, 1, 6. And what is our new row 3?
0,
0, 2, 1, 14.
Good. We still have 1, -1, 0, -4 for row 1, and 0, 1, -3, -7 for row 2. What would be normally the next step after we finish column 1? What's the first thing that we always do in any column?
I'm sorry, what was the question?
What's the first thing that we do in any column? Do we get zeros first or do we get a 1 first?
1 first.
That's right. And the 1 is always on the element that has the same row and column. So normally we would get a 1 where D22 is, but we already have a 1, so yay. So how can we get a 0 where we currently have a -1?
you add a +1.
Good. And we're going to use row to do that.
Row 2.
Good. And what about where we currently have a 2? How can we get a 0 there?
-2. You're going
Good.
to add it.
And what row are we going to use?
2.
Good. All right, good. So now we've got row 2, row 1, new row. Two is 0, 1, 3, -7. Row 1 is 1, -1, 0, -4. What is our new row 1?
It's 0. Wait, no. 1, 0, -3, -11.
Good. And why are we not freaked out about this -3 and -11?
Don't you still have to do one more round
Yes.
of the,
Yes, because we have more than 2 things in that row. We're going to have more steps. So we don't worry yet that this -11 can't be nicely divided by -3. Okay, so let's write down our new row 1. There's Juliet. All right, so we've got 1, 0, -3, -11, 0, 1, -3, -7. And we still need to find our new row 3. So we have row 2, -2 times row 2, row 3, and the new row 3. Where row 2 is currently 0, 1, -3, -7. Let's see, and row 3 is currently 0, 2, 1, 14. What is -2 times row 2?
Um, 0, -2, 6, 14.
Good. And when we add the second and third rows,
Zero, 0, 7, 28.
excellent. And why do we feel okay about these numbers?
it divides, 28 divides into 7 equally.
That's right. Very good. So let's see. We've got our new row 3 is 0, 0, 7, 28. Have we finished column 2?
Yes.
Yes, good. So column 2 is done. Column 1 is done. What's the first thing that we need to do in column 3?
Turn the -3 into 1.
So we're going to turn the 7 into 1. So that we're just looking at the diagonal.
Oh, yeah.
So D3, 3, D2, 2, D1, 1. So all of the elements that have the same number for row and column. And how can we turn 7 into 1?
Multiplying it by 1, 7.
Good. So that we've got 0, 0, 1, 4. We still have 1, 0, -3, -11, and 0, 1, -3, -7. All right, great. What is the last step?
Making them zeros, the -3s.
That's right. And what row are we going to use?
Row 3.
Very good. What are we going to multiply by row 3?
-3s. No, a 3. In the first one, plus row 1, second one plus row 2, new row 2, new row 1. So let's see, our current row 3 is 0, 0, 1, 4. 3 times row 3, row 1. Let's see, so what is 3 times row 3?
0, 0, 3, 12.
All right. And row 1 is currently 1, 0, -3, -11. And when we add those second and third rows, what do we
It's
get?
1, 0, 3. No, 0. That one's a 0. And then a 1.
Good. And we've got row 3, 3 times row 3 plus row 2 to get the new row 2. And I'm just going to copy the first 2 rows from the left side here. So we've got 0, 0, 1, 4, 0, 0, 3, 12. And our current row 2 is 0, 1, -3, -7. And what do we get when we add the second and third rows?
Zero, 1, 0. And then that one's a 5.
Excellent. So our final matrix is going to be, let's see, 0, 0, 1, 0, 5, 0, 0, 1, 4, and 1, 0, 0, 1. And we just need to check. Wait, were all those positive? Let's check. We've got 2x minus y minus 2z is 2, -x plus 3y plus z is 4, and 3x plus 2y plus 3z is -20. All right, and we're going to use, let's just write it down. We've got x, y, z equals 1, 5, 4. So I'm just going to substitute in 1, 5, 4 for x, y, and z. And I think it's not going to check. Well, that's very interesting. So let's go back and check why it's not checking. Because I can see, I'm just looking at this last one. These are all positives and it's not going to equal a negative. So this is fun because we're actually using the fact that we checked it. So we started off by switching, excuse me, the second row and the first row. And I don't know where I wrote that down. So let's go ahead and write it down. Again. So we did row 1 switch with row 2. That'll give us 2, -1, -2, 2, and -1, 3, 1, 4. And then we still have 3, 2, 3, -20. All right. So what do we need to do at this step? Could everybody mute? I'm getting some feedback. Okay, good. All right, so what do we need to do? We've got one more step to get a 1 in D11. Good.
I'm sorry. Where are we now?
We're redoing this one because our answer didn't check. The main one that didn't check, or the one that I noticed right away, was that we have 3 positive numbers added together and they're not going to equal a negative. So we're doing it again.
How'd you get that matrix though?
Oh, okay. So the first thing I did was switch row 1 and row 2. So the original matrix, thanks, Tyler. The original matrix was 2, -1, -2, 2, -1, 3, 1, 4, and 3, 2, 3, -20. And then I switched row 1 and row 2.
That's a whole different problem. I think we were doing the x minus y equals -4.
That's why it
2x.
doesn't check.
Okay,
Yes,
I'm
you're.
sorry.
Oh
I
my
was
gosh.
so lost.
Oh my gosh. Okay, that's why it didn't check. Because I'm plugging it into the wrong equations. Thank you so much. Okay, so yes, here are our equations. X minus y equals -4. 2x plus z equals 6. And y minus 3z equals -7. And our solution is indeed 154. Yeah, 154. Oh, this is better. What would I do without y'all?
I didn't even notice.
Well, I obviously didn't either. So let's see, we're checking the solution 154. So 1's for the x's, 5's for the y's, and 4's for the z's. And the first one is 1 minus 5. Yay. And then 2 times 1.
2 plus 4 is 6.
Yay. Oh my gosh. And 3 minus 4. And what is 5 minus 12? Exactly right. Oh, this is so much better. Yay. I wondered what in the world. Why didn't we have it work? But it did work. Okay. Any questions before we're going to look at something a little bit, it's a little bit of an extension. Do y'all want to do another regular one again before we do an extension? Okay. So now we're going to look at kinds of systems, because we've been assuming all along that the two equations have one intersection point. But we could have parallel lines, and we could have the same line. A consistent system has a solution, so an inconsistent system has no solution. An example of something where there's no solution is if we have the same slope and different y-intercepts. In other words, if we have parallel lines. We can have two different kinds of consistent systems. We can have one that's called independent, where they cross at one point, one unique solution. Or we can have a dependent consistent system where they're actually the same line. So this is the same line. So we've got infinitely many solutions, but they're all on that same line. So consistent, there is a solution. Inconsistent, no solution. And for inconsistent, we have to have parallel lines. And then if we have a solution, we can have one solution that would be called independent. And that means we've got one intersection point. Or we can have a dependent consistent system where the two lines are actually the same. So from now on, we're going to answer at the end if this, whether or not the system is consistent, inconsistent, independent, or dependent. And let's start out. So we have 3, 2, 19, 4, -1, 7. And what's our first goal? What's our first goal?
D11 equals 1.
Excellent. How do you want to do that?
You can subtract row 2 and row 1.
Good. It looks like it's going to be 2 steps also. So we've got row 1 plus negative row 2 to get a new row 1. So we've got row 1, row 2, negative row 2, and the new row 1. Row 1 is 3, 2, 19. Row 2 is 4, -1, 7. -1 times row 2 is what? And -1 times 7. And then we're going to add the first and third rows so that we get so what are we going to have if we add the first row and the third row?
I want to say 1.
It's almost 1. 3 minus 4.
-1,
There you go. And then 2 plus 1
3,
and 19 minus 7.
12.
Excellent. So that's going to give us row 1 of -1, 3, 12. We still have 4, -1, 7 for row 2. And do we need to do one more thing to finish the very first step?
We're gonna multiply, right?
Yes.
Row 1 by 1.
By positive or
Oh.
-1.
I'm sorry, -1.
That's right. Good. So our new row 1 will be +1, -3, -12, and row 2 is still 4, -1, 7. Now what do we want?
We want 4 to be 0.
Good. And what can we do to get a 4 to be 0?
We can add -4.
Good. And what row do we need to use?
Row 1.
Good. Okay, so we've got row 1, -4 times row 1, row 2, and the new row 2. Row 1 is 1, -3, -12. Row 2 is 4, -1, 7. What is -4 times row 1?
-4, 12.
48.
Mm.
Okay. Okay. The reason why I'm pausing is that -4 plus 4 is 0. 12 minus 1 is 11. And oh, here it is. It's okay. 48 plus 7 is,
55.
yeah. Why is that okay?
Because you can divide 11 by it.
Yes, that's right. So our new system, row 2 is now 0, 11, 55. Row 1 is still 1, -3, -12. And we're going to go ahead and do what?
Divide or multiply.
We're going to multiply by
1 over 11.
very good. And that is the same result as if you divided by 11. So that our new row 2 will be 0, 1, 5, 1, -3, -12. And we have one more step.
D12 to equal 0.
Good. And what do we want to add to -3?
+3.
Good. And what row can we use? Or should we use?
Row 2.
Perfect. All right, so we've got row 2, 3 times row 2, row 1 in the new row 1. Row 2 is 0, 1, 5. What is 3 times row 2?
0, 3, 15.
All right, and row 1 is right now 1, -3, -12. When we add the second and third rows, we get
103.
yay. So our final matrix, 1, 0, 3, 0, 1, 5. So what is our solution for this matrix?
3, 5.
Yay. And let's go ahead and check it before we move on. So we have 3x plus 2y equals 19 and 4x minus y equals 7. And the solution we're checking is 3, 5. And we're plugging in 3 for x and 5 for y. 3 times 3,
9,
and
10,
yes, yay. And then 2 times 3, 4 times 3,
12, minus
and 12.
5.
Yay. Okay, how many solutions did this question have? How many? So since we had one solution, the system is consistent because there's a solution. And since there's only one solution, it's also independent. All right, well, let's do example 13. What is the matrix that we're going to operate on this time?
Uh,
4, 1, 3,
Excellent.
-2, 1, 1/2, 4,
Good. This time, the only way to get a 1 where we have in the D11 position is by, we're going to have fractions this time. Do you see that if we add any multiple of the second row, we're going to get a 0. So we have to multiply by the reciprocal of 4 or 1/4 to get a 1. Is that all right so far?
yes.
Okay, good. So we've got a 1, we've got some fractions, so we're a little bit nervous, but we're okay. What do we need to add to -2 to get 0?
2.
Good. And what row do we use? Which column are we in?
2. Oh, row 1, a column 1.
We're still in column 1, so we're going to use row 1.
Row 1.
So 2 times row 1 plus row 2 will give us a new row 2. All right. So we've got row 1, 2 times row 1, row 2, and a new row 2. Where row 1 is a little bit ugly. 1, 1/4, 3/4. So let's see, 2 times 1 is okay. What is 2 times 1/4? So here we've got 2 times, or 2/1 times 1/4. What is that value?
2 times 1 is 8. One half.
Six over 4. Miss, I can't hear you.
We can't hear you, Miss Mel.
Is your audio off? I can't hear. She's
I messaged her.
Oh boy, let's see how long this takes. Maybe someone tried calling her? That could get her attention more. I think she saw it now.
Pobrecita, she's all into the problem.
So hyper focused. Did it work?
I think she noticed.
The long pause.
the class is over, right? Technically.
Is it? What time is it again? What time does class end?
at 12:15.
12:15.
We're just a little bit over, just a tad.
Ju-
Just a
Juliet,
tad.
you're in charge, Juliet.
No, please, not me. I'll be steering y'all the wrong way.
Well, class time has officially ended, but it's just run out over a bit. And then there's technical difficulties.
Well,
Poor
we
Miss
made it this
Nell.
far.
That is true. Any other message from Miss Nell?
No.
What if the video just suddenly cuts off and Zoom ends?
I guess that would mean that class is over.
A sign. Cannot- Something has happened to my audio. Sad face. Wait, we can also message in Zoom. But I don't know if she will see it. See you Thursday. Okay.
Bye, Miss Nell.
Bye.
Bye, Miss Snell.
Bye.
See you Thursday.
Bye bye.